In this tutorial, we will build an online first contact screen using SwiftData. You'll see real records in the list in a minute, and we'll begin to design the model and also sync to Firebase later. So this is the app at the moment. I'll now show you Firebase. You can see there's no records there. So now I will create a few records. That's the first record. But I will disconnect the Wi-Fi so that the data isn't pushed to Firebase. I now save the record to SwiftData. I'll create another record. And save again. And you can see that the records have not been persisted, they haven't been sent to Firebase because we're not online at the moment. So now what I will do, I will stop the simulator and then rerun it. And then now I will attempt to push the records to Firebase, the two records, which are at the moment stored offline. So I just pull to refresh. Oh, I've forgotten to turn the Wi-Fi on, but that's a good test anyway, so you can see that it really works. I pull to refresh it again. But there's something wrong with the Wi-Fi. Has it worked now? So let's check Firebase. And now you can see, if I click on Contacts Collection, now you can see that the two records were submitted to Firebase. My record and also Fred blogs. And we can also delete the record from SwiftData, and the records will also be deleted from Firebase. Just refresh. You can see now it just includes my record only. In part 1, we built the UI and the SwiftData model. In this video, we build the layer that makes everything scalable, a repository that handles create, update, delete, and later sync, which are CRUD operations, without rewriting the UI. The first thing we need to do is to create a new Swift file. Name the file contact repository. And then we need to create our protocol contact repository that will implement sendable. We also need to import SwiftData and then create our function signatures. Local, that should be load, local, sync throws, which will return a contact entity. Create another function, signature, create, name, string, email. The email is string, phone, string, async throws, and then for update, it's similar, so I'll just copy and paste what we just done previously. Although we have to also apply the ID so that the correct information is updated. Throws should have an S at the end. Also delete to delete a record, so we have to apply or supply our ID, async, this should be async throws, and then sync throws. So that will push local changes and then pull the remote changes from Firebase, that line there. So this protocol that we just created is a contract between the UI layer and data layer. The UI doesn't care if the data comes from SwiftData, Firebase, or both. It just calls these functions. The next thing we need to do is to create an actor of default contract repository, which will implement contact repository. And the purpose of the actor is to handle race conditions, which is used in threading. Private let local contact local database. Well, that doesn't exist at the moment, so maybe it's best we create that first. Okay, let's create that first. The contact local database. So the contact local data source is another protocol that we need to include. Really, this should be in a separate file. Or maybe it's best to put it in a separate file now, so I just will create another file. So that's called contact local data source. Import SwiftUI. I mean SwiftData. Paste it there. Go back to the previous one and delete this one. And now we can continue with the actor. So that should be contact local data source. We also need another variable. Let's remote contact remote data source. So that's another protocol we need to create. So I'll just get it from the clipboard. So now I've got the other protocol. We need to create another Swift file. Since this is a different protocol, and then let's go back to the empty file. Where is it now? There it is, contact remote data source. We need to import SwiftUI again for this file. I mean SwiftData. And then just continue where we left off. So that should be contact remote data source. Then we need another variable, last sync key, contacts dot last sync at. And the next thing we need to do is to create our initializer. So the next thing I'll do is just copy and paste the code from the clipboard. And then just fix some of the errors and then explain some of the codes. Cannot find sync status in scope. Maybe it's a spelling issue. Let's see, sync status. Sync status, that seems correct. And maybe I should take out this enum, take it out of the class, and then make it more public. That might help. See if it works now. Yeah, seems like that fixed it. Yeah, just wait for it to compile. Yeah, it's compiled. So on lines 25, this is dependency injection. We pass in a local and remote, and that makes it more testable. And with these functions, these CRUD functions, these are like quite boring, which is a good thing. The repository forwards CRUD to the local data source. So the app works offline instantly. And delete is a soft delete. We mark it deleted locally. Then we sync the deletion later. And really, this is what makes the offline first feel instant. The UI updates from SwiftData immediately. And the sync function has two phases, which includes push, then pull. First we update the local changes, then we download remote changes. As you can see here, on line 63 and 64. And also dirty means created or edited offline. We convert to a DTO and then offset remotely. And also pending delete means we soft delete locally. Now we delete remotely, then remove locally. In part 3, we will wire this repository into the view model and replace a direct SwiftData calls so the UI becomes one clean layer. Then we'll add Firebase without rewriting anything. If this topic is where you keep getting stuck in SwiftUI, that's exactly what I help people with in one-to-one mentoring. There's a free clarity call link in the description.